Welcome you all to the session on system software. Today just I am going to explain that in two pass assembler, that is the pass to assembler. So in the previous session just we had a discussion how actually that pass one assembler will work. As we know that due to some kind of forward references we cannot, the assembler cannot process the entire file at once. So hence it requires different kinds of passes. So among those just we are discussing pass 1 and pass 2 assembler here. So during pass 1 what actually it is going to be happen? So just it is going to take the source file as an input file. So in that input file just it is going to process only that label field and the mnemonic field. So the label field, it is for constructing the symbol table for pass 2, and the mnemonic field which is used to verify whether it is a valid mnemonic value or not. So in the mnemonic field, either we can get the instruction set or some kind of assembler directive. So some of the assembler directives will be processed during pass 1. So just if it encounters any symbols in the label field, what actually is going to do is it is going to searching for that symbol in the symbol table. So if it is already there, it is going to set an error flag, it is a duplicate key or duplicate entry. If it is not there, then it is going to enter that particular symbol into the symbol table along with the current location counter value. So then it is going to move to that mnemonic field. In that mnemonic field just it is going to verifying whether it is valid mnemonic value or not by referring that opcode table. So if it is valid one, so just simply it is going to adding that 3, or 3 is nothing but is the instruction length to the location counter. Otherwise it might be get what some kind of assembler directives in the same mnemonic field. So if it is an assembler directives like word, byte, or reserve word, accordingly it is going to process it accordingly what is the length which is required for such kind of things, accordingly that locator counter value will be incremented. So during after pass 1, what actually it is going to produce is, it is going to construct the symbol table for pass 2, and the intermediate file which is having the source code along with the address for each and every instruction. The actual translation is going to be done during pass 2. So in the pass 2 just it is going to refer only, it will not touch that what label field. So just it is going to refer that mnemonic field as well as the operand field or symbolic field. So that mnemonic field, it is going to be converted into its equivalent opcode, that is the 2 hexadecimal digit, and that whatever the symbol field and whatever the operands which are defined, so for that symbols it is trying to get that symbol value from the symbol table, so to translate that symbol name into its address, like that. So just I will take the example in the next session, just I will take the simple program, that entire program how actually is going to processing during pass 1 and pass 2 I will explain. For the sake of this, for explaining this kind of this algorithm, just I am taking a simple example here. So during pass 2, the actual translation is going to be done during pass 2. So what actually is going to be done? What is pass 2 and how actually it works? So in pass 2, so first just it is going to refer this intermediate file which is being created by the pass 1 algorithm or pass 1 assembler. So first it is going to read the input line from that intermediate file. So what actually it is going to do is, so just after generating an object code for each and every instruction, finally it is going to create an object file. So that object file, as I already explained, there are 3 kinds of records are there: header record, n number of text records, and one end record. So if it is relocation, some of the records will be added in future. Right. So here just it is going to read the first input line from the intermediate file. So if the opcode is equal to start, what actually it is going to do is just it is going to write that listing line to the object file. It is having the header file. What actually it is going to do is just it is going to write the program name. What is the program name? Just we are taking, that is the copy, and what is the address? It is there in the opcode of start, it is 1000. So just it is going to write the header record to the object program. After that it is going to initialize the first text record. So that object file, it should have only one end record and one header record. It might be having n number of text records. The text records, it is having the actual object code which is being generated by the assembler, line by line for each and every instruction. So in this case, after that, so it has to process all the instructions for translating for generating an object code for all the instructions until it encounters the end, just what I have explained during pass 1 assembler. So just it is going to process all the lines. So while opcode is not equal to end, so if opcode is not equal to end, just it is going to read the first line. So opcode is equal to end, no. So next, this is not a comment line, yes, this is not a comment line. So then it is going to search that opcode for that opcode table for that opcode. So STL, so in the opcode table is nothing but is a static table which is having all the entries of all the opcodes of all the instructions. So then STL, it is going to get that opcode for that STL. Yes, of course the opcode of that STL, it is 14. So just it will get that value. So just it is going to translate that mnemonic field into mnemonic value into what? Its opcode. So after that it will move to the next one. It won't touch the label field here because the label field is processed during pass 1 only. So what actually is going to do is it will get into that mnemonic field. So it means it has to convert its symbolic value into its equivalent address. So where actually this is the instruction is at the memory location 1000, but at the memory location 1033, that redirect which is defined, return address which is defined. The return address which is defined at the memory location 1033. So directly it cannot jump to that 1033 here. Instead of doing that one, for converting this new symbolic value into its equivalent opcode, what actually it is going to do is it is going to searching for that opcode, the value for this return address in the symbol field. So then it is going to consider as a key. Just it is going to searching the entire that symbol table, whether that return address is present or not. Yes, of course return address is present. Yes, return address is there. So then it will get that value. What is the value of the return address which is there in the in the value field? It is 1033. So then it is going to convert that return address into 1033. So means if there is a symbol in the operand field, what actually it is going to do, once it convert that mnemonic field into its equivalent opcode, so then it is going to searching for this return address. So return address, if there is a symbol, yes, of course there is a symbol. In some of the instructions there is no symbol in the symbolic field. For example, R sub instruction. It doesn't have any kind of symbols in the operand field. So means if there any symbol in the operand field, is search the symbol table for the operand. So if present, if found, so just it is going to store the symbol value as an operand address. So what is the symbol value? 1033. So just it is going to store that symbol value as an operand address in the object code. Suppose if that operand it is not present in the symbol table, if the operand is not present in the symbol table, sometimes the user is using using some kind of the memory variables. Sometimes he may be forgetting to define that variable in the label field. So it is missing in the label field. So during pass 1, just it is going to observing that label field only, whatever the labels which are present in that symbols which are present in the label field, just it is going to having the entries in that symbol table. It is not observing in this symbolic field. Sometimes the user is defining that symbol in the symbolic field, is forgetting to define that same symbol in the label field. So on that time that label is missing, the symbol is missing. So on that time it has to store. Suppose return address it is there, but if it is not present in this field, so what actually it is going to do is it is going to set an operand address as 0. It is going to set operand address as 0. So then it is going to set an error flag. So this is another possibility. It is going to set an error flag. This is another possibility. So sometimes else 0 as an operand address. For some of the instructions, it doesn't have any kind of operand field. For example, R sub instruction. R sub instructions, it doesn't have any kind of operand address. So means operand value. For that first it is going to convert. That R sub into its equivalent opcode. Then it is searching for the symbols in the symbol table. In that symbolic field. Is there any symbols in the symbol table? Symbolic address field? So no. So what actually it is going to do is simply it is going to set 0. But for this it doesn't rise any error flag here. So there are three possibilities are there. Please do remember there are three possibilities are there. So in the mnemonic field, in the symbolic field, either if any symbols are there, so then it is going to searching within that symbol table. If that symbol is already there in the symbol table, what actually it is going to do is, so just it is going to set that operand address as the symbolic value which is present in the symbol table. Sometimes the user is defines using that return address here is forgetting that defining that return address at the label field. So on that time during pass 1 the return address will not enter into the symbol table. So on that time what actually is going to do is, yes, of course it got the return address here. So but it return address if it is not available in the symbol field, so what actually it is going to do is it is going to set the operand address as 0, then it is going to set an error flag. Otherwise some of the instructions it is having only that mnemonic field, so not operand field. So for such kind of instructions also it is going to setting that value as 0, so then it is not set it is not going to rise any kind of errors. So this is another way. So there are three possibilities are there. So means if there is a symbol in the operand field, then it is going to search the symbol table for that operand. If found, then it is going to store the symbol value as an operand address, else store 0 as an operand address and rise an error flag. Means it is undefined, symbol, it is not defined at the label field. Else store 0 as an operand address, so then it is going to assemble this what object code. So just you have to remember, in the mnemonic field either we can get the actual instruction or some kind of what assembler directives like word, byte, reserve byte and reserve word, like that. So for the reserve byte and reserve word, it is not going to generate any kind of object code, only that constant value, just it is going to convert that value. So actual processing is going to be done during pass 1 only. So but during pass 2 it is going to convert that actual translation is going to be done. So means just it is going to convert that constant, that value into its equivalent to constant value. So means else if means for this else if statement, it is if opcode is equal to some kind of opcode is present in that opcode table, so then it is going to process such kind of things. Suppose if the opcode is not present in the what opcode table, means what, it is an assembler directive. So if it is assembler directives, means it is going to searching, it might be byte or word. If opcode is equal to byte or word, so then it is going to convert that constant into object code. Suppose if I am defining word value has 3, right? So here the label name, it is 3 here. So it is the word integer value. What is the value? That is the constant value. So just it is going to convert that value into its equivalent to constant value. So if the object code, suppose if it is not fit into that current text record, so then we have to initialize one more record, that 14101033, it is going to be written to this text record. The text record is capable of holding 60 hexadecimal digits, means 10 object code, 10 instructions, just it can hold of 3 bytes length. So if it is exceeded in that particular text record, the next text record will be initialized. If it is a small program, only one text file is enough, one text record is enough. If it is a longer program, one text record is not enough to fit the object code. So for that, just it is going to defining some more what text records. So then it is going to writing the listing line, means it is going to write the listing line here. So next it is going to read the next input line, again go to that same thing, it is going to be incremented to the 1003. So what is that? C loop is there. So what is the instruction? That is J sub redirect. Redirect instruction is there. So for that it is going to searching for that J sub which is present in the opcode table or not. Yes, it is present in the opcode table, that is the 48. So then redirect which is present in the symbol table or not. Yes, of course the redirect it will be present in the symbol table at the memory location 2039. At the memory location 2039. So then it is going to convert this value as an operand address. So then it is going to what convert, sorry, if the object code, again it is going to write this listing line into the text file. So if the text record is not enough, then it is going to initialize the new text record. So then it is going to add the object code to the text record. So that then we have to write the listing line to the object file. So means just we have to process all the instructions until it encounters the end assembler directive. Until it encounters the end assembler directives. Once it encounters that end assembler directives, it comes out from that loop. So then it is going to write the last listing line to the object file. So then it is going to making the complete object file, which is having different kinds of records, that is the text record, header record, and that is end record, like that. So this is how actually that pass-to assembler will work. Please do remember, during pass 1 just it is going to processing only that label field and the mnemonic field. Label field, what actually it is going to do is, just if it encounters any kind of symbols in the label field, what actually it is going to do is, it is going to construct the symbol table. That symbol table, just it is searching for that label in the symbol table. If it is already there, it is going to set an error flag, it is a duplicate entry. Otherwise it is going to enter that symbol into the symbol table along with the locator counter value. So then it is going to processing that mnemonic field whether it is a valid one or not. If it is valid one, so simply it is going to write the complete line into the intermediate file along with the address. So the symbol table and the intermediate file will be the input to the pass-to. The actual translation is going to be done during pass-to. The object file is also being generated by pass-to assembler only. So during pass-to, it won't touch that label field. So just it is going to convert that mnemonic field into opcode. So for that, to get that opcode, just it is going to refer that opcode table. So if it is not, suppose again then it will move to the mnemonic field. So if there are any symbols there are possibilities are there. One possibility, the symbol is there, but the symbol is defined in that symbol table. Another possibility, symbol is there, symbol is not defined in the symbol table. Another possibility, there is no symbol in the symbolic field, because some of the instructions it doesn't require any kind of symbols. For example, R sub instruction. So in this case, what actually is going to be done is, if any symbols are there in the symbol field, symbolic field, then it is going to do is, it is going to searching for that symbol in the symbol table. So if it is there, then it is going to set operand address as its value. Otherwise, it is going to set and it is going to put that 0 in the operand address field. Then it is going to set the error flag. It is the undefined symbol. So if it is not there, simply it is going to set that 0 as an operand address. So this is how actually it is going to be done during pass-to. So means before that it is going to write the header record and it is going to initialize the first text record. So just it is going to, after generating an object code for each and every instruction, just it is going to write the object code for that record. If that text record is not fit, it is not possible to hold all the data, then another text record is going to be initialized. So means it might be having a number of text records. So then it is going to process all the instructions until it encounters the end assembly directives. Finally, it is going to create an object file for the loader to be loaded into the primary memory. So this is all about that pass-1 and pass-2 assembler of an assembler algorithm. So right, so here this is the, already I explained all those things. That object program, it is having 3 different kinds of records, that is the header record, text record and end record. The header record, the column 1, which is having specifications of means it is going to specify what kind of record it is. Column number 2 to 7, it is having the program name. Column number 8 to 13, it is having the starting address. It is in the form of hexadecimal digit. The starting address, which is going to be calculated during pass-1 only at the end of pass-1 algorithm. So means the end address minus starting address, then we will get the object code length, that is the entire program. Again 14 to 19, then it is having the length of the object program in bytes. Starting address, it is 100, again length it is 1078 is the length of that program. It is going to be written like that. So next, the text record, the column 1, which is used to specify what kind of record it is a text record. 2 to 7, the starting address of that starting address in the text record, from which address to which address the text record it is having. From 8 to 9, it is having the length of the object code in this text record, it is of 2 hexadecimal digit, and 10 to 69 means 60 bytes of 60 hexadecimal digits just we can fit into that text file. So end record, the column 1, which is having that end record, it is E, column 2 to 7, it is having an address of the first executable instruction. The address of the first executable instruction means it is holding that the address of the first instruction, that is the 1000 it is having. So this is the example of what that object file of the code, just the example just we have taken. Just you can observe that in this program, so in this program there are one header record, one end record, so it is having 5 text records. So the header record, it is having the first column name, it is head, H, it is the program name, it is copy, the starting address and the length of that program, that is 207A minus 1000 is nothing but 107A, but it is represented in the form of 6 hexadecimal digits. So next, which is the text file which is been initialized, the starting address of the text file. So means in the same example, so here this is the object code which is being generated for the text file. So means the text file, it is capable of holding 10 different kinds of instructions. It is capable of holding 10 different kinds of instructions. So means it's been started from the memory location 1000 to 1000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So till here, so just it can hold it. So means from this object code to this object code. So what is the object code? It is from this object code, the first text file it is holding like that. So means you can observe that. So the starting address, it is 1000. So 1E, it is nothing but is the length of that object program. Just I will calculate from 10332 to 002D, just it is going to be what stored till now. So means the length of that text record is going to be calculated by using what is the length. So means 101E minus 100. So means the next program counter value means we need to take. So means 1E is the text record length in that particular file. So means that text, if that text record is not it is not enough to fit that code, so then the next text record is going to be initialized, it is going to be stored like that. So here this is how actually the memory locations, it is going to be shown like this. At the memory location 1036, 1033, 1030, 102D and whatever the instructions at the 102A, 1027, that object code is being what generated. Our object code is loaded, so at the memory location. So this is the example program just we have taken there. So in this case, the main drawback of pass 1 and pass 2, to avoid 2 passes, that is pass 1 and pass 2, we can done the same thing by using one pass assembler. So means one pass assembler, what is the main thing just we can go with, that is pass 1 and pass 2, only due to that forward references. How actually we can avoid the forward references? So what is the forward references means? So once we have used that or using that variable is going to be defined after the instructions. So means to avoid such kind of forward references, before using that variables, we need to define that variables at the initially or at the before that instructions. So means forward references can be resolved in one pass assembler too. So just we have to add the linked list to the symbol table to keep the track of unresolved references, and we will discuss that one pass assembler design in next classes. So here this is how actually it's going to be done, that is pass 1 and pass 2 assembler will work. Pass 1 during pass 1 and during pass 2. Actual processing is going to be done during pass 1, actual translation is going to be done during pass 2. Pass 2 only is going to generate what an object file for the loader to be loaded into the primary memory. So means one pass 1, pass 2 is different, one pass is different. So whatever the things which is going to be done by pass 1 and pass 2, the same thing is going to be done during one pass, that is the one through single pass only. So that is called as one pass assembler. We will discuss that one pass assembler in upcoming sessions. Thank you.